In question 11, we have a figure. This figure is given. Now find the ratio of the pressure in the two parts of the vessel. Solution 11. Now the number of moles are same. We know that the formula for P1 is nRT over V, nRT over 3V, because V1 is V and V2 is 3V. So after this, P1 by P2 will come out to be 3 by 1. In question 12, we need to find the RMS speed of hydrogen molecules. Solution 12. So the RMS speed will be root 3 RT over M, 3 into 8.3 into 300 over 2 into 10 to the power minus 3, which will give us 1930 meters per second. Now let temperature at which it becomes twice of this. This is, let me write exact value. Exact value is this much. So equal to root 3 into 8.3 into T, temperature at which the RMS will become double. So from this, T will come out to be approximately 1199.98 Kelvin or 1200 Kelvin. In 13, a sample of 0.177 gram ideal gas is there. Calculate the RMS speed of the gas molecule. Solution 13. RMS root 3p over rho. 3 into 10 to the power 5 into 10 to the power minus 3 over 1.77 into 10 to the power minus 4. So it will be around 1301.8 meters per second. Question 14. We need to calculate temperature of the air. Solution 14. So average kinetic energy is 3 by 2 kT. So 3 by 2 kT equal to 0.04 into 1.6 into 10 to the power minus 19. So T will be equal to 309.178 Kelvin approximately. In question 15, we need to find average time taken by a molecule to travel a distance equal to the diameter of the Earth. Solution 15. So now average velocity is 8 RT over pi m. 8 into 8.3 into 300 over 3.14 into 0.032. So T will be distance over time 6400 into 2 445.25. It will be around 28747.83 seconds, which will be around 7.985 hours. In question 16, we need to find the average magnitude of linear momentum of helium molecule. Solution 16. So it will be root 8 RT over pi m. putting every value. Remember to put temperature in Kelvin. 1201.35 meters per second. So momentum will be mass into average velocity, 6.64 into 10 to the power minus 27 into, so it will be 8 into 10 to the power minus 24 kilogram meters per second approximately. In question 17, we need to calculate ratio of the temperature of hydrogen sample to helium sample. Solution 17. So average is given by this formula. So once you take the ratio, it will be like this. T1 by T2 will come out to be 1 by 2. In 18, at what temperature mean speed of molecule of hydrogen gas equals the escape speed from the earth? Solution 18. So the escape velocity is given by root 2gr, and mean velocity, average velocity 8 RT by pi m. So when we equate them, we will have this value, which will after simplification give us meters per second. In question 19, we need to find the ratio of mean speed of hydrogen molecule to nitrogen molecule. So this is solution 19. V average equal to root 8 RT over pi m. V average for hydrogen and for nitrogen 8 RT into pi 20 and 8 RT. So it will give us 3.74 approximately. In question 20, we need to calculate ratio of mass of molecule in left part to right part. Solution 20. So 3 RT over m1, 8 RT over pi m2 by the given things. So m1 over pi m2 will be 3 by 8, m1 over m2 will be 1.1775. In question 21, estimate the number of collisions per second suffered by molecule in sample of hydrogen at STP. Solution 21. So mean velocity, average velocity 8 RT over pi m, so it will be 1.23 into 10 to the power 10, and total distance is 1698.96 meters. So the number of collisions will be 1698.96 over 1.38 into 10 to the power minus 7, 1.23 into, this will be 1698.96 10 to the power 10. The distance will be 1698.96 meters, and this will be 1.38 into 10 to the power minus 7. In 22, calculate the mean speed of molecules, and suppose molecules strike with Angle 45 degree. How many molecules strike each square meter? Solution 22. In this question, the A part will be 8 into 8.3 to 300 over 3.14 into 2 into 10 to the power minus 3. So it will give us around 1780 meters per second approximately. And in B part, force exerted will be mv cos 45 degree minus mv cos 45 degree. So it will be 2 mv cos 45 degree. So ultimately force will be root 2 mv. Number of collisions molecules striking per unit area per second will be force over root 2 mv into area, pressure over root 2 mv. This is actually momentum. So pressure over root 2 mv, 10 to the power 5 root 2 into 2 into 10 to the power minus 3 into 1780 over 6 into 10 to the power 23. So after solving this, we will get number of molecules will be 1.2 into 10 to the power 28. In question 23, we need to calculate the pressure of the air in the tube given. Solution 23. So P1 V1 over T1 is equal to P2 V2 over T2. So now V2 is V1 plus 2% of V1, that is 102 V1 over 100. So T into 2 into 10 to the power 5 into V1 over 293 equal to P2 into 102 V1 over 100 into 313. So from here P2 will come out to be around 209462 pascals. In question 24, we need to find the mass of the gas that leaks out by the time the pressure and the temperature inside the jar equalize with the surrounding. Solution 24. So we will have P1 V1 equal to N1 R1 T1, N equal to P1 V1 R1 T1. It will come out to be 1.5 over 8.3 into 4. Now after this M1 will be N into M, that is 1.5 into 8.3 into 4 into M, which is 32, which will give us 1.446 approximately. So P2 V2 equal to N2 R T2, N2, let this be N1. So N2 will be equal to P2 V2 over R T2. So it will be 1 over 3 into 8.3 or 0.040. So M2 will be 0.04 into 32, 1.285. So the difference is 0.1608 gram. In question 25, we need to calculate the radius of the bubble as it comes to the surface. Solution 25. So here P1 V1 T1, P2 V2 over T2 1.33 into 10 to the power 5 4 by 3 pi 2 into 10 to the power minus 3 cube over T1 equal to 10 to the power 5 4 by 3 pi r square over T2. So from this R will come out to be 2.19 into 10 to the power minus 3 . In question 26 we need to find how many moles of air have leaked out. Solution 26. So n equal to P1 V1 over RT1. So it will be around 0.1606, and in second scenario P2 V2 RT2 it will be around 0.02. So the number of moles that have leaked are 0.16 minus 0.02, around 0.14 moles. In 27, calculate the temperature at which the internal energy is increased by 12 joule. Solution 27. U equal to 3 by 2 nRT internal energy 3 by 2 mmRT. So according to the question T dash will be, after simplification, something like this. Around 196 degrees Celsius. In question 28, during an experiment, we need to find the temperature when it expands to a volume 2V. Solution 28. PV square equal to constant P1 V1 square equal to P2 V2 square. So nR T1 V1 V1 square nR T2 V2 V2 square. We will obtain T1 V1 equal to T2 V2. So TV equal to T1 into 2V. So T2 equal to T by 2. In 29, a vessel is there. We need to find the pressure of the mixture in this vessel. Solution 29. So number of moles of O2 1.6 over 32 0.05, and for H2 2.8 over 28 0.1. Sorry, 2. So after this the mixture will be NO2 plus NH2 over V into RT. So when we put all the values, we will obtain 2250 pascals. In question 30, we need to find the maximum height of the mercury column that can be put on the piston. Solution 30. So P1 V1 equal to P2 V2. 75 rho G 100A 75 plus H rho G 100 minus H to A. So from here H square minus 25H equal to 0. H will come 25 centimeters. In question 31 we have been given this figure. Show that two vessels A and B with rigid walls containing ideal gas is given. So show that the pressure and temperature satisfy the following equation. So this is solution 31. So PA dash 2V over T, PA V over TA, T PA over 2TA, and similarly P dash B over T equal to PB over 2TB. Now add these two equations. We will obtain PA over 2TA plus PB over 2TB half PA over TA plus PB over TB. So P by T will come out to be half PA TA plus PB TB over TB. PA dash plus PB dash is equal to P. In 32 we have to find mass of air. Container is now placed in another batch. Find the mass of air in this container, and container is now closed. Find the pressure. Solution 32. So for the A part, PV equal to nRT1. It can be also written like this. So PV will be M will be PVM over RT1. Putting all the values, we will find it will be 0.065 grams. B part, same formula will be there. Here it will be 0.0465 grams. C part, P into 50 into 10 to the power minus 6 equal to 0.0465 over 28.8 into 8.3 into 273. So P will come out to be 0.07316 into 10 to the power 6 Pascal.